question example 10, moving parallel plate capacitors plate. Okay, so again in the previous lesson we discussed when we move the plates, so that the energy stored becomes the separation, and capacitance also stores depends on the separation. Okay, when we move the plates apart, so what is the new value of energies and the new value? So I explain in detail. So what the plates of parallel plate capacitors having area A, separation X, and connected to the battery with the voltage V. While the connected to the battery, the plates are pulled apart until the separation becomes 3x. So separation becomes 3x, we have to find initial and final energy stored on the capacitor. Okay, so in order to find the energy stored, so we use the formula energy stored when the separation is x. Suppose initially when the separation between the plates is x, okay, we connect with the battery to voltage V. Initial separation is x, so the capacitance C1 is equal to epsilon naught A over x. So this is our equation number 1. Now we put this the energy stored is 1 over 2 C V square. This is formula for energy stored. So that the C1 is equal to epsilon naught A over x. So we are left with the half epsilon naught A over x into V square. We just put the value of C1 in this equation. Okay, now when the separation becomes 3x, separation between plates becomes 3x. Okay, now the C2 becomes epsilon naught A over 3x. Instead of x we write 3x. Now the formula U2 becomes half C2 V2 square, C2 V square, C2, because the potential remains the same because the battery is same, so only write C2 V square. So half C2 is epsilon naught A over 3x into V square. So U2 is half 1 over 2 epsilon naught A over 3x into V square. Okay, now we have to find the change in energy on the capacitor. So the change in energy is U2 minus U1. So we just have to subtract these two formulas, equation 2 and equation number 3. We have to subtract these two formulas. So we know that this all the terms are constant, so we can take the difference between these two values. See, if I take the difference between C2 minus C3, so C2 minus C3, so I have to write here 1 minute, C2 minus C3, so C3 minus C2 actually, so half epsilon naught A over 3x V square minus half epsilon naught A over x into V square. So we know that all the terms are constant, only all the terms are common, so half epsilon naught A over x V square, all terms are constant, all terms are common, we take common, but only from the first term U2 we have 1 over 3, from the second term we have minus 1. So 1 over 3 minus 1, this will give us 3, 1 minus 3, that gives us minus 2 over 3, minus 2 over 3, minus 2 over 3 into half epsilon naught A over 3x. So 2 will be cancelled with the 2, and I think so 1 minute 3x. So this 3 is here, instead of 3 we have only x. So we have epsilon naught A over 3x, epsilon naught A V square over 3x, V square is also common. Okay, so epsilon naught minus epsilon naught A V square over x. So this is the change in potential energy, okay, for the part 1, part A. So part B, so we have to find the work done in pulling. So in order to calculate the work done, we use the formula for work done. We know that work done from moving plates from distance x to 3x, is equal to W is equal to the line integral of f dot dl x to 3x. Limit of integration is x to 3x, because initial distance is x and now we move the plate to 3x. So F is equal to, as we know, that electric force F is equal to QE. F is equal to QE. Now we put this formula in this equation, integral x into 3x QE into dl, QE into dl, and we know that the E is equal to potential gradient equation, E is equal to V over D. So the D is actually, we know that the D is 2L. Why it is 2L? Because if the plates are initially this distance apart, x distance or L distance apart, now we move the plate, one of the plate to the 2L distance, 2L, because the final distance is 3L or 3L or 3x, you can say that. Okay, so now we have moved the D is, because this electric field intensity is equal to the change of potential divided by 2L. So potential change is, so the distance is 2L. Here you can see that D is 2L because E is equal to del V over D. So this D is actually 2L. So we use E is equal to V over 2L. So if we put V over 2L, so we have to put the E is equal to V over 2L. So now we modify this equation and we can write E is equal to V over 2L, and we put also value of F is equal to QE, E is equal to V over 2L, we put E is equal to V over 2L, and we also put Q is equal to CV, and C is equal to A epsilon naught over L. C is equal to A epsilon naught over L. So we also put Q is equal to CV, Q is equal to CV, and Q is equal to CV, and C is equal to epsilon naught A over L into V. Okay, equation number, suppose this is equation number 1, 2, 3, and then equation number 4. This is equation number 4. This is equation number 5. Equation number 6. Now we put 5 and 6, value of E and Q in equation 4. Put 5 and 6 in equation 4. So we are left with the W is equal to x to 3x, x to 3x, x to 3x, QE, Q is CV, Q is epsilon naught A over L into V, and E is V over 2L, QE, and then dl. So we rearrange this, V and V square, L and L square. So we are left with the epsilon naught A x to 3x epsilon naught A V square over 2L square into dl. So we take all the other terms outside the integration, x to 3x epsilon naught A and V square, and we took only the integration term, we took only the L square, 1 over L square into the integration. So x to 3x. So 1 over x square, we separately integrate this 1 over L square into dl. So we take L minus 2 dl. So this will give us minus 2 plus 1. Power rule, we apply power rule, minus 2 plus 1. So this will give us L power minus 1 over minus 1. So minus 1 over L. So is the integration of this one, minus 1 over L. So epsilon naught A V square into minus 1 over L. So we can write epsilon naught A V square over L. So this is minus, negative. So epsilon naught A V square over L. So the limit of integration, finally we put the limit of integration, epsilon naught A V square over L, and then we put limit of integration. 2 is also there, because 2 is also there, 2 is also constant, so 2 is also constant, so 2L, epsilon naught A V square over 2L, and the limit integration is x to 3x. Now we put upper and lower limits. So when we put upper and lower limits, so we are left with this one, upper limit minus lower limit. Upper limit 1 over 3x, lower limit is minus 1 over x.